Okay, today I'm going to give you a few tips to go over ETCAI's power supply challenge. Some of the things to keep in mind when you go through this. This is a troubleshooting exercise. It gives you several different types of power supplies. We have a single diode half-wave rectifier. We have a full-wave rectifier using 2 diodes, and we have a full-wave rectifier using 4 diodes, the bridge rectifier. You can test it both with an oscilloscope as well as with a voltmeter. I definitely recommend that before you begin these challenges, go through and do a practice of all of them with no faults, so you kind of have an idea of what your measurements should be. The other thing I really want to point out to you is this animated scenario overview here. It's kind of giving us an overview of what we're looking at in our power supply circuit. And here we have a 4-diode bridge rectifier circuit, and they're giving us some reminders along the top of what are some things we should be considering. This is with an oscilloscope up here in this model here. So look through this, and this gives you a good overview. So right here they're looking at the AC input, and now you're looking at the secondary voltage, and now the capacitor, and then the voltage regulator itself. And on that voltage regulator it was 5 volts. So take some time to go through this, and it explains this. It explains your oscilloscope is going to give you a peak-to-peak reading, and don't forget our voltmeter, it gives us an RMS reading. So when we look at 120 volts AC, the peak-to-peak value of that is going to be 120 times 1.414, and that gives you peak value, and then times 2. So we're approximately 320, 330 volts in that range, and they could use anywhere from a 110 volt input to a 125 volt input. So just kind of a general idea to keep in mind. It's actually a lot easier as you go through this. You can really get a good sense is the sine wave within the range that it needs to be in. You don't have to do the calculations to work it out. So let's take a look at one of these and see what we can do to figure out how to solve it. This is the half-wave rectifier with a voltmeter. So we're troubleshooting the half-wave power supply using a voltmeter here. There are 2 modes, an AC and a DC mode. Pretty straightforward as you go through and look at a power supply. There's some key points that you want to start at, and then you either work your way backwards or you work your way forward, depending what the results are here. The specifications of this particular circuit up here, we have 120 volt input. Our secondary coil should be a 12 volt AC output. And then the diode rating, the capacitor ratings, and they're using an LM7807 voltage regulator to give us a 7 volt output, 7 volt DC output. You can use this as a principal reference. Always pay attention. What is the desired regulator output, and what is the desired secondary output on your transformer? Those are good things to compare against as you're doing your base troubleshooting here. So here, let's start out in a logical manner. We're going to start with the AC sense mode for our voltmeter, and I always start right at their primary coil. And if I have an AC voltage, in this case we got 117, which is within our range of 110 to 125. We got a good AC voltage going in. That means my fuse is good. It also means my switch is good. If this read 0, we would back up and go on the other side of the fuse. And if we got our voltage then the fuse would be the problem. If we end up having to go to the other side of the switch, then obviously our switch was our problem. In this case, we're good. So move forward. Let's look at the secondary side of this. So we take a look at the secondary, and we have an 11 volt output. That is within range of their 12 volt secondary. So we can move forward. Now, once the diode gets into play here, we got to change our voltmeter to a DC sense. So go ahead and click that to DC, and let's get on this side of the diode. And so we see a 15 volt output there from the diode, and That's our output with our rippled waveform from our capacitor. So really, when I measure here, I'm measuring between this side of the diode and ground. So I'm measuring the capacitor, I'm measuring across what is our resistor here, and I'm measuring the input side of my voltage regulator. So anywhere I go along there, I'm going to get that same 15 volt reading. Okay, let's take a look at the voltage regulator. The center pin is to ground, and so you should get a 0 value there when you're reading that. Let's look at our output, and we do see a problem here. This upper pin is a problem. It should be reading 7 volts, and it is not. So it is the upper pin that's the problem in this particular circuit, and that is our voltage regulator. So go ahead and select that and grade the selection. We're good. Let's move on and see what our next one's got. So again, start with an AC sense. Go to your primary coil, and primary side, we've got a good input voltage. Go to the secondary side, we got a good secondary output voltage. Let's change to a DC sense and take a look at our diode. We've got a decent voltage there. Let's come on this side of our and we should get our 0 there, and then again we got a voltage regulator problem. So that's our problem. Grade the selection and move on. So we start with an AC sense. Let's go to our primary. We got a good 110. Look at our secondary. We're good there. Let's take a look. This we're going to have 6 volts on our voltage regulator up, and we got 0 volts on our voltage regulator. So we look here, okay, and we're 0 volts coming into our voltage regulator. Let's step back a little bit. Our diode is our issue, and that's I didn't check that earlier, but diode 1 is going to be our problem because on this side of the diode, our secondary voltage is there, and then diode 1 has a 0. So grade that selection. We're good. We can move on from here. New power supply, AC sense. Let's go ahead and okay, so here's a situation where we have 0 volts AC at this primary, so it's either my fuse or it's my switch. So let's come on this side of the switch. Okay, and we're on this side of the switch, so we know the fuse is the problem. We don't have to do anything further there. So say fuse, we'll grade the selection, and we're good to go there. Our next power supply, AC sense, let's go there to their primary. Again, similar situation. Let's go on this side of the fuse. Okay, so here's a situation where even when we have eliminated the fuse from between the probes, we're still getting 0. The switch is our problem. I don't even have to go over here, but I will to show you that there's my line voltage. So the switch is my problem. Grade the selection, and let's move to our next power supply. AC sense is where we're going to start. Let's look at the transformer. We've got a good primary input. We don't have a good output on the secondary side. Now that doesn't mean the secondary is the problem. The primary could be the problem. So let's first check the secondary. What we're going to do is use an ohm meter and check our secondary coil. I'm just going to double click on the secondary side of our transformer, and it pulls it out, pulls an ohm meter out for me. Okay, and notice it says secondary 1, secondary 2, so it's the secondary side. I'm going to turn this on. Okay, and you see that you have infinite resistance there. If that coil was good, we would have a low resistance value with our ohm meter. Our secondary coil is bad here, and that's our problem. If we happen to have a good secondary, and because we got 0 on our output over there, we know our primary would be our bad coil. We wouldn't necessarily have to test the primary side. So in this case, it's our secondary. We're going to say it's secondary. We have to turn this off, and then we can grade the selection there. Okay, and move our next power supply. Start with an AC sense. There's your primary input. It's good. Secondary input looks to be good. Let's check the specifications of this guy here. Okay, we're an 8 volt let's take a look at our diode. So coming on the other side of the diode, well, let's go to a DC sense. My fault there. But coming on the other side of the diode, we have 0 volts, so diode 1 is our problem. So a very systematic approach as you take a look at this. And let's take a look at our next power supply. We're going to do an AC sense with this one. Start there. We got 122 coming into my primary. We don't have anything on the secondary. Remember, you got to pull the transformer out. So let's pull that out. Let's measure the continuity of the secondary coil. Turn your ohm meter on. So here you see there is a low resistance there. There's some continuity through that coil. So I know I don't have to check it. I know the problem is the primary coil over here. Now it does dock me points if I end up turning this around and checking the primary side. But I know it's a primary coil, so I'm going to turn this off like this and go to transformer primary. Okay, I know it's a primary because the secondary had good continuity, so the primary had to be the open side of that. So grade that right, and almost done here. Looking at the, we look at our AC input, AC output. Again, let's double check this transformer. Okay, we'll look at the secondary side. I suppose I should show you how to look at the primary. We'll look at the secondary side. Okay, in this case, it's the secondary that's bad. It's got an open infinite resistance, so the secondary is the bad side. And we'll turn that off. Transfer secondary is what's bad. Grade the selection. We're good to go. Next power supply. We're going to go with our AC sense there, 110. We're good. Let's see this side of it. Okay, let me just show you how to check the primary side. I've been clicking on the secondary side. I'm going to double click over here on the primary side. Double click the primary side. Notice this says P1, P2. We'll go ahead and turn this on. Okay, so primary has a resistance. Therefore, it was the secondary side that was bad on our transformer. So I'm going to go ahead and say it is the transformer secondary. We'll turn this guy off. And we'll grade that selection, and we're right there. Just a couple other items that we haven't encountered in here. You can check the resistance value based on the code. It should be about a 4.7 k ohm resistor. If you double click on that, you can use an ohm meter to check that. Generally, there is not a need to do that unless you find a fault up here when you're assessing the voltage regulator. And the voltage regulator should be giving you whatever the specification are for the particular regulator. And if you're getting something higher than that, then you may want to go back and you either have a regulator problem or you have a resistor problem. You can go back in and you can double check your resistor then. Using some basic logic as you work your way down this bus line here, you should be able to eliminate the diode, the capacitor, or the voltage regulator as a problem, or the resistor as a problem. So just use some basic common sense as you go through there, and then you go ahead and finish your score out. It does take points off when you use the ohm meter to do your checks and do your assessments. And so that's why I didn't get a perfect score there, because it did penalize me for using the ohm meter on my my transformers. You got a 50-50 chance there, but it is the best way of knowing whether you're right or not. So good luck.